Hi guys, this is just an extra example about transformations for those of you who want a little bit more explanation. So I'm going to do an example with a reciprocal function, 1 over x, okay? And I hope that this helps you guys. So when we are transforming any function, first we identify the parent and we make a table of values for the parent, okay? Now, I don't always do this. For instance, I don't always do this with sine curves, but you always can do it. Even if I don't do it in examples, you're always able to just start with a table of values. But you want to do a smart table of values. So you don't just want to start putting in 0, 1, 2, 3, 4, 5. I mean, you can if you really have no idea where to start. But if you remember kind of the general shape of the curve, it's helpful to come up with a smart table of values. So you know that 1 over x looks something like this, right? Or I hope you do. Okay, so we need to get this section here and this section up here. So to do that, I'm going to put in an x value of -2. And 1 over -2 is negative of half. Okay, so that's this coordinate right here. Okay. Then I'm going to put in -1. 1 over -1 is just -1. So it's this coordinate right here. And now you could say, well, let me just switch over to 0, but I don't want you to do that because that doesn't show enough of the shape that we're going to be going down here. So we need to put in -1/2 to get that shape. Now 1 divided by -1/2, if you put it into your calculator, you'll see that that's -2. Okay. So that gives us enough points to make this shape. Oh, it's approaching this asymptote here. And it curves down and approaches, oops, this asymptote down here. Okay. So x0 gives us a vertical asymptote because that would break it. So x equals 0 is a vertical asymptote. Okay. Then again, I could just put in 1 and then I would get this point, and then 2 and I would get 1/2, but I want to show the curve going up here. So I'm going to put in +1/2. Oops, that's +1/2. So let's get rid of that. Half, because 1 divided by 1/2 is 2. 1 will give me 1 over 1 is 1. And if I put in 2, then I get 1/2. So again, I get this nice looking curve that approaches both its vertical and horizontal asymptotes. So at this point, I'm going to label the horizontal asymptote as well. So the horizontal asymptote occurs at y equals 0. So I want to include these in the table of values to remind you to include them in your sketch. Okay, so now let's say I want to find g at x equals 3 times 1 over, let's do 1/2 x plus, we'll say 1, and then plus 4. Okay, so what I want you to do first is always identify the parameters. So your a is equal to 3, your k is equal to 1/2. Now, d is not equal to 1. We have to factor out k to see what d is equal to. So 1/2 x plus 2, right? Because think about it, to multiply back to x plus 1, you would be 1/2 times x and then 1/2 times 2 to get this 1. So my d value is actually -2. Okay, and my c value is 4. So that means everything's being vertically stretched by 3, horizontally stretched by 1/2, horizontally stretched by 2, okay, be careful, left 2, down 4. Okay, now I want to change the asymptotes first because that will help me understand where my graph is going to be in the kind of the general shape of my graph. So the asymptotes are just changed when we move things left or right. So everything's being moved to -2. So my vertical asymptote is going to be here. See this awesome line I'm drawing? At x equals -2. And my horizontal asymptote is going to be moved up 4. So at y equals 4. So all the action kind of is going to be happening right around where they meet. Like it's going to be like here and here. So I just kind of want to give that reference so I'm not freaking out later. Okay, so now I'm just going to use my table of values. So remember, it's always x over k plus d. So all my x's are being divided by a half, and then I'm subtracting 2. So another way of thinking about being divided by a half is being multiplied by 2. That looks nicer, doesn't it? Okay, so I can come up with my new table of values here. Oh, that's nice, Mrs. Sweens. Okay. So all these x values are being multiplied by 2 and then subtracted 2. So -4 minus 2 is -6. -2 is -4. Minus a half times 2 is -1. 1, that's -3. Okay, this is -2, which is still my vertical asymptote, which I already drew. A half times 2 is 1. 1 minus 2 is -1. 1 times 2 is 2. 2 minus 2 is 0. 2 times 2 is 4. 4 minus 2 is 2. And then I'll deal with my horizontal asymptote when I get to my y's. Okay, now what's going on with my y's? So I always do ay plus c. So 3y plus 4. Okay, so 3 times -1/2 is -1.5. -1.5 plus 4 is 2.5. Okay, if you do this on a calculator, that's fine. That's -3 plus 4 is 1. -6 plus 4 is -2. 6 plus 4 is 10. 3 plus 4 is 7. 1.5 plus 4 is 5.5. And then my horizontal asymptote is 4. So I'm not really going to be getting everything on the graph the way I drew it here. So this is a problem that often comes up when you have a preset thing. Okay, so if this happens to you, you might want to start from scratch, or you need to extend this up or change your scale or something, but we'll see what we can do here. So -6, 1, 2, 3, 4, 5, 6, and 2.5. Okay, -4 and 1, and -3 and -2. Okay, so notice that it's approaching each asymptote not as quickly, and that's because of the stretching in both directions. Okay, you want to make sure that you get to the point though where you're leveling this out so it doesn't look like it's going to cross over the asymptote. Okay, if I had just left it here and put an arrow there, see, it would have looked like it was going up there. So you got to make sure you get to the point where it's being leveled out. Now I have -110. So this is 4, 5, 6, 7, 8, 9, 10. So I'm going to cheat and say that that's about there. 0, 7, 1, 2, 3, 4, 5, 6, 7. And 2, 5.5. 1, 2, 3, 4, 5.5. Okay, so again, I need to make sure it looks like I am approaching the asymptote and not going back up. Okay, make sure it really looks like it's approaching the asymptote, not like it's going to curve back up, and then this is going that way. All right, so you can check a point, like let's put in 0 and make sure I get 7. Okay, a half of 0 is 0, plus 1 is 1. So 1 divided by 1 is 1. 3 times 1 is 1. 3 times 1 is 3. 3 plus 4 is 7. That point fits. So try a few of the points. But I mean, you can think about it. This looks right. It looks like it's been vertically stretched. as well as horizontally stretched. And it looks like it's been moved left 2, up 4. So it's all good in the head. But notice how drawing those asymptotes really does help give a context of where your shape should be. Okay, so that was an extra example of transforming a reciprocal function. I hope it helped you learn even more.